Hi guys, hope you guys are having a wonderful day this morning, and I hope you guys are also interested in looking at some more Cramer's rules. Truth is, I actually do enjoy using Cramer's rule. Its application may look a tad on the cumbersome side because of the presence of so many letters and variables, but it's super straightforward when you really get the hang of it. So I'm here to help you guys get the hang of it. Okay? So Cramer's rule for solving equations more in the form of a 3 by 3 matrix is a little bit longer, but not too shabby. Here goes. So Cramer's rule to solve a system of three equations involving three unknowns in particular, say x, y, and z. Those are your coefficients. Of course, if you had to set up a 3 by 3 matrix, it would simply be written using these coefficients of x, y, and z on the left-hand side of your equation. Okay, guys, so I hope you guys can see that that's essentially a 3 by 3 matrix on your left-hand side. And on your right-hand side, we just have our variables. If you wanted to, you can call this equation 1, you can call this equation 2, you can call this equation 3, and so on. And if you go back to my previous video, you can actually perform a proof that shows how you actually generate these three equations. I'm going to show you guys down below. However, I am just going to apply the previous video and say by extension, you can solve for values of x, y, and z using the same thought process of finding values for x and y that we did in the previous video. Now, if you want to find values of x using Cramer's rule, all you have to do is set your first column, right? You want to set your first column to these values on your right-hand side here. Those values are B1, B2, and B3. If you are interested in finding y values, then you would like to set your second column to those values, B1, B2, and B3. And finally, if you would like to solve for values of z, by the way, I like to write my algebraic z with a cross there, so it's easily differentiable from the digit 2, because sometimes I tend to write my 2 like a z. It's just a preference, but you'll see a lot of people write their algebraic z with a little cross across it. It's just to differentiate, okay, guys? Right. So if you would like to find the value of z, similarly, you set your third column to those values, B1, B2, and B3. And then it really isn't that bad. It isn't as hard as you think to remember. Your denominator is just simply your entire 3 by 3 matrix written, and then the remnants of the columns that I have not written in yet will simply be the values which supposed to originally be there. You can take them from your matrix on the bottom, so that'll be A12, A13, A22, A23, A32, and A33. Please forgive me, I live very, very close to a building, so sometimes if my timing isn't right, I get some sound from there. I'm sorry, my microphone cannot take it out. I don't think anybody is going to say I am deliberately inputting any sort of music into my videos, but it's just my location, guys. Okay, so essentially what you do is whichever variable you would like to solve for, if it's x, Then you make sure that your X column or your first column, sorry, is set to those values B1, B2, B3. If you want to find for Y, you set your column 2 to B1, B2, B3. And if you would like to solve for Z, you set your third column to B1, B2, and B3. So guys, it's just a matter of a lot of writing, but not essentially such a difficult process. Okay, so what we're going to get into now is I'm actually going to show you guys a full-on example so you can see its application. Okay, so now you might also realize why they don't have those formulas on a formula sheet. It's not that bad to remember. So here's a question. Using Cramer's rule, we want to solve for x, y, and z in the following system of equations. Okay, so let's just say we had 2x plus y plus 3z equals 1, 4x minus 3y plus z equals 7, and then finally we have x plus 2y plus c equals 5. How do we use Cramer's rule to solve for these? Well, very easy. We have generated, as above, we have generated 3 formulas. I think I'm just going to do one, just so you guys get the idea, the relative idea, because it's simple. Okay, so on a denominator, what you do is you simply set the determinant of the entire matrix. So those values are 2, 4, 1. You have positive 1, negative 3, 2, we've got 3, 1, and 1. Nice and easy. And we know if we are finding the x value, then we need to set that first column to those values given on the right-hand side. Okay, and then we can continue writing the rest of our rows and columns using the existing values of our matrix. So all we have to do on the numerator is simply find our determinant of a 3 by 3 matrix. If you cannot remember how to find the determinant of a 3 by 3 matrix, please check my previous videos where it clearly details how to find that. But the determinant of this matrix is simply 1 by the determinant of negative 3, 2, 1, 1, subtract 1, the determinant of 7, 5, 1, 1, and then finally plus 3 by the determinant of 7, 5, negative 3, and 2. I'm hearing such lovely birds outside. I'm very close to a mango tree. For those of you who don't know what a mango is, it's a very sweet fruit that is very indigenous to the Caribbean region or regions that have very warm climates. And I have a tree in my backyard and I'm sitting very close to there right now, and the birds are just having a go. And it's just so lovely to be teaching maths to you guys right now and listening to those birds chirp. So relaxing. Okay, so so on the denominator, to find the determinant of our matrix, and then we subtract. Remember, the pattern is plus minus plus. So we'll have 1 with 4, 1, 1, 1, plus 3 with 4, negative 3, 1, 2. Oh, I almost wrote curly brackets there, guys. Whoopsie. Right, because we're finding the determinant. So hopefully I didn't make any mistakes as I usually do in writing out all those numbers, but I think I'm good. And finally, I'll just tell you guys the answer. This is supposed to work out to give you a value of 4. Please do remember that these are all determinants, so you would have to sidestep and calculate those individual determinants. So essentially, this is how to apply Cramer's rule to solve for a system of equations, of 3 equations involving 3 unknowns. It's a very, very nice, wonderful formula, guys. It eliminates the need for stuff like, having to do very, very long simultaneous equations and so on, solving and substituting and so on. It's just so wonderful. Once you really understand the concept of Cramer's rule, and you can use a little tips and tricks of just simply replacing a particular column with the values on the right hand side. I think this method is a definitively hands-on one that a lot of students enjoy using at the end of the day. So I hope that was very helpful. If you guys would like to see tons more examples of using Cramer's rule to solve 3x3 equations where I do it in more detail, show full working, etc., please comment down below and I'll be sure to respond with a tutorial. So I look forward to seeing you guys in the next video, where I will be getting into finding the inverse of a 2x2 matrix as well as the inverse of a 3x3 matrix, which means we'll have to do a bit of cofactors. So please make sure you like and subscribe if you want to see more videos, and that is what's coming up. So all the best. Good to be with you guys, and bye.